Welcome to the Explainer. All right, let's jump right in. To all our 8th grade learners out there, get ready, because today we're looking at something way bigger than just numbers on a page. We are diving deep into the complete laws of exponents and, really, discovering the fundamental rules of order. Now, I want to kick things off with a principle that applies to pretty much everything we do. 1 Corinthians 14:40 says, "Let all things be done decently and in order." Just think about that for a sec. Just like our lives need order to avoid total chaos, algebra desperately needs rules so we don't end up a confused, frustrated mess. When things are orderly, it all just kind of clicks. So, right out of the gate, you might be wondering, why do these rules even matter? Why should we care about mathematical laws at all? Well, it's all about bringing that awesome concept of decency and order straight into your math workbook. Once you get these rules down tight, you completely bridge the gap between staring blankly at a problem and feeling absolute, total mathematical confidence. Let's break down exactly what you'll get out of this. When you bring all these exponent laws together, it's literally like having a mental cheat sheet. You're going to make way faster decisions. You'll drastically reduce your mistakes, which means building some serious confidence. Plus, you're mastering a tool you're going to use for, well, all of algebra. You'll know exactly when to add, subtract, or multiply those tiny little numbers. It's an absolute game changer for avoiding bad choices and feeling completely ready for whatever math class throws at you next. Okay, here's our roadmap for today's explainer. First, decency and order. Second, we'll hit the exponent summary table. Third, special exponent rules. Fourth, we're going to solve a problem together. Fifth, your homework challenge. And finally, number 6, education, morality, and peace. Let's get to it. All right, moving right along to section 2, the exponent summary table, covering the laws of exponents. Consider this your ultimate toolkit. This covers the whole shebang, everything you need to handle multiplying powers, dividing them, and even dealing with those tricky negative and zero signs. Keep this toolkit in the back of your mind as we go. So let's look at the product of powers versus the quotient of powers. The absolute crucial thing here is how the operations relate. Check this out. When you multiply the bases, you actually add the exponents, like x to the m times x to the n, that becomes x to the m plus n. But if you divide those bases, you subtract the exponents. It's a perfectly logical system. Multiplication goes with addition, division goes with subtraction. See? Total order. And that brings us right to our next 2 rules. Power of a power versus power of a product. The key here is noticing exactly where the exponent is hanging out. If you've got an exponent sitting outside a parenthesis, like in power of a power, you multiply it by the exponent on the inside. So x to the m, all raised to the n, is just x to the power of m times n. Now, if you have a product inside, say a times b, that outside exponent actually gets distributed to every single thing inside. It's like dealing out cards, super neat and incredibly orderly.
All right, section 3. Let's look at special exponent rules, specifically zero, negative, and rational exponents.
First up is the zero exponent rule, and honestly, this one is brilliantly simple. The rule says any non-zero number raised to the power of 0 equals 1. So x to the 0 equals 1 as long as x isn't 0. Take 7 to the 0 power, for instance. It's just 1. Think about how wild that is for a second. It doesn't matter how massive or insanely complicated the base number is. If that exponent is 0, all that chaos just magically simplifies into a nice, clean number 1. Okay, moving on to the negative exponent rule. A negative exponent basically means you divide by that number of factors instead of multiplying. So x to the negative n power, that equals 1 over x to the positive n power. For example, x to the negative 3 is literally just 1 over x to the third. So the big takeaway here is that a negative exponent is really just a fraction in disguise. It just flips the base to the bottom of the fraction to restore order. No need to panic when you see a minus sign floating up there, just flip it. Then we've got the rational exponent. This one states that x to the power of 1 over n equals the nth root of x. So 64 to the 1/2 power is exactly equal to 8. Let's demystify these fraction exponents real quick. A 1/2 power is really just a super clean, orderly way of writing a square root. Once you make that connection, rational exponents aren't scary in the slightest. Let's jump into section 4. Let's solve it together. We'll go step by step through a real example. All right. Here is our challenge. We need to simplify the expression 2x to the 4th, y to the negative 2, all inside parentheses, and that whole thing is squared.
Now, looking at that jumble of numbers and variables, it probably looks like a total mess at first glance. But remember what we talked about. Our rules of order are going to sort this out in no time.
Let's actually walk through this together, step by step. Step 1, we use the power of a product rule to distribute that outside square to the 2. So 2 squared equals 4, nice and easy. Step 2, we use the power of a power rule for our x. We multiply that inside 4 by the outside 2, which gives us x to the 8th. Step 3, we use power of a power again, this time for the y. We multiply -2 by 2, and that gives us y to the -4. And just like that, boom, we hit our final answer, 4x to the 8th, y to the -4. I mean, look at the logical certainty of that. We completely tamed the chaos just by following the rules, one step at a time.
Which brings us to Section 5, your homework challenge. Time to practice those new skills.
I'm passing the baton to you now with these 5 challenges. Number 1, simplify 3x squared, all squared. Number 2, what exactly is the difference between x to the -3 and x to the +3? Number 3, simplify a squared, b to the -1, all cubed. Number 4, simplify x to the 0, y to the 4th. And number 5, match the rules to their names. Listen, you've got the ultimate toolkit to completely crush every single one of these problems now. You are absolutely going to nail this. And finally, Section 6, Education, Morality, and Peace. Let's look at the biblical connection here. Let's take a quick breath here and shift gears just a little bit. This explainer draws from the HeroesmartAcademy Godly Learners series, which shares a really profound idea. Education without morality will hurt. Basically, being smart is totally pointless if you just keep making bad choices that cause pain. There's a direct parallel here. Just like breaking math rules creates wrong answers and total confusion, trying to live life without moral rules, well, that leads to some pretty painful life choices. Order really does protect us. In fact, Romans 8:6-7 promises peace of mind to everyone who keeps their mind spiritual. Doing things decently and in order, whether we're talking about applying the laws of algebra or making choices in our everyday spiritual lives, it brings a guaranteed peace of mind. When your life is orderly, the chaos just naturally fades away. So I want to leave you with a final thought to mull over today. Will you choose to bring the rules of order into your math and the peace of God into your mind? Really think about that as you tackle your homework later. You've got the tools now. Embrace the order, enjoy the peace, and keep on learning. Thanks so much for joining me on this explainer today, and I'll catch you next time.